Hi everyone, this is Rémi Lafage from Monera. Today in this video I'm going to show you how the metamodel and the local code are able to communicate. In fact, how we are able to call a metamodel on the WhatsOpt server, and it will introduce the REST API that the WhatsOpp server exposes. So to recap the previous episodes, we have, as always, our Cellar analysis. We have, for that analysis, created a DOE, and then from that DOE we have generated a Cellar metamodel. So we have here the same inputs and outputs, but we have just one component, which is our metamodel. So that metamodel, we are able to use it, let's say, creating a new directory. We can just pull the analysis containing the metamodel. And the nice thing is that we can directly call the metamodel like that and get some results with the values of the inputs we have entered. So how this is implemented? In fact, behind the scene, I'm going to show you the code which has been generated. Just a moment. Okay. So this is the code of the Cellar component we have generated, and we can see here that we have some boilerplate in Python to make a REST API call using the requests Python model. So we call that URL, and we can see here in fact the line which is responsible for the actual call, which is this one, where we are using requests to make a put call to the URL, and here we need, as we want to get some prediction at some point, we pass some x points as input. So the input of the predict method of metamodel is a matrix, and as a result, symmetrically, we get some here some results in the response, and we convert back from JSON to the outputs for OpenMDAO. So here we have a simple REST API call using the Python language, and the nice thing is that this is possible from any language, programming language we want. So those API are documented in WhatsOpt, and I'm going to show you where you can find the information. It's in fact here in help, API documentation, and we have here the services that are exposed by WhatsOpt. So regarding metamodeling, we have 3 methods. So this is in fact the Swagger user interface, which is embedded here in WhatsOpt, and it is used to document REST API following OpenAPI standard. And here, for the first service, we can see we have a get method on this URL to get all the metamodels available in the WhatsApp server at the moment. So for instance, we can see here for that method we have no parameter, and here we can see an example of results we get from that services. So it is a list of object, JSON object, and we can, the nice thing is that we can just try it out here directly from that interface. So as I am already authenticated here I don't have to enter any password or API key. So I just execute the web service. Here you have the curl command if you want to use it from a shell window. But the nice thing, here I have an error, but it's normal because I'm not on the right server. I just select the right server here, and then I can execute again the command, and here we can see we get a JSON structure, which is just a list of all the metamodels available, and the last one, it is the one we saw just before. So we can see it has 83 as identifier, and we have some information about the analysis which contains that metamodel. But well, this is just the list, and then we can go to the next service, which is the service which allow to get some more information about the metamodel. And specifically I need to know the dimension of the inputs and the outputs I get from that metamodel. So here I can try these services directly with the ID 83 and then execute. And then we can see here we have some more information about the metamodel. We can see that it is a kriging method, metamodel from the SMT library. And then again all the information about the analysis with the owner of the analysis. And more importantly, we have here the input and output specification of the metamodel. We can see that it takes 3 scalar input, which are x and the 2 components of the z vector. So first component z0 and second component z1. And as a result, we get the 3 values f, g1 and g2. So this is important to use that service to know the interface, in fact, of the metamodel. And then once we have that information, we can use the third service, which is the more important one, because it is in fact the prediction of the metamodel, the ability to run the prediction. So here again I can use my metamodel, just specifying the identifier, and here we see that we have to specify the input, the x, where we want the metamodel being where we want to predict. So as default there is just a 0, but I know that my inputs are need 3 values, so the x values, for instance 2, and then the z0, let's say 5, and z1 let's say 2, I've just taken the same inputs as before, and then I can execute my meta model, and here we can see we have the results from the meta model. So the y outputs, which are respectively f, g1 and g2, and I can check with my my execution here from my analysis, my OpenMDAO code, and we can see we have the same value. And here, for instance, I can compute the meta model for several inputs. So let's say 3, for instance, like that, and then execute again. And we can see here in the curl command that the parameter is passed here as a 2D array, and then as a y outputs I get two rows which are the f, g1 and g2 values. So it ends the services related to metamodeling. WhatsOpt exposes other services about analysis, and also it exposes an optimizer from Onera, but it is another story. So for now it ends my my demonstration. Thank you for watching, and see you next time. Bye bye.